How you find point of inflection is, the first step is you find f inverse of f prime of x. Then the second step is using f prime of x, you find f double prime x. Then the third step is you set f double prime x equal to 0 and find values of x. This is the third step. Now, after finding these values of x, you divide your number line into different ranges. Divide the number line into segments. And then the next step would be you check in which segment your f double prime x is greater than 0 or less than 0. You check the value of f double prime x in all the segments. Okay, and then in the same point, if f double prime x is greater than 0, it is concave up in this segment. If f double prime x is less than 0, it is concave down in this segment. And then point number 6 is you identify the points of inflection. So point of inflection are those points where f double prime x will change either from up to down or from down to up. Okay. Mm, all right, let's do this. So we'll keep on going back to our slide where we wrote down the points. So first step is, so we have to identify the points of inflection in this graph. The first step is find f prime x. So let's do the first step. F prime of x in this case would be equal to x to the power of 4 minus 4 by 3 x cube plus 8. Yes, this is f prime x. I've not done anything special, just you bring down the power and you reduce it with 1, and we have been doing this all along. Then second step is find the prime of this prime. So you do a double prime, and this becomes 4x cube minus 4x square. That's it. And the third step is set this double prime equal to 0 and find values of x. So you put this double prime equal to 0. Let's change color. So this is 4x cube minus 4x square. Let me take 4x square common. This is just x minus 1 equal to 0. From here you can get your x is equal to either 0 or 1. The next is divide the number line into segments and check where your double prime x is positive or negative. So let me have a number line. I'll have 2 points on this. This is 0 and this is 1. Now, if I plug in 2 in this double prime, that means this range, it's going to be a positive number. So this thing will be concave up. If I plug in negative 1 in this will be negative, so this will be concave down. Now, a number between 0 and 1, let's say is zero point 0.5. So if I plug in 0.5 in this will be a negative, so this is also concave down. This was my step number 5. Now identifying the point of inflections. A point of inflection is when this double derivative goes either from positive to negative or from negative to positive. So in this case, at this range, it's concave down and then down. It's not changing direction. It is changing direction only at this point, at x equal to 1. So there is only one point of inflection, x equal to 1.